Section 9.2.7, we want to be able to determine the t-value in each of the cases. In Part A, we want to be able to find the t-value such that the area in the right tail is 0.10 with 9 degrees of freedom. So, to find the t-value, we're going to use the t-distribution table. We're first going to locate the row for 9 degrees of freedom. And next, we're going to locate the column for where the area of 0.10 is in the right tail. And then we're going to find the point where these two values meet. So let's take a look at here. Okay, so again, we know that the area in the tail is 0.10, and we're looking at 9 degrees of freedom. So here is the degrees of freedom. So here is 9 degrees of freedom. And then we're going to go to the area of 0.10 that's in the right tail. So therefore, we're going to see the value to be 1.383. So we can say that the t-value is 1.383. Okay, and so in words, we would say that the t-value with an area in the right tail of 0.10 and 9 degrees of freedom is 1.383. Okay, and if we just wanted to draw the bell curve, right, then what would that look like for where this t-value is? So if we wanted to draw the bell curve, okay, then that t-value is going to be on the right of whatever that mean is. So therefore, t would then be 1.383. Because again, this is in the right tail. Now, in Part B, it says find a t-value such that the area in the right tail is 0.05 with 14 degrees of freedom. So now we're going to look for 14 degrees of freedom with an area of 0.05 in the right tail. So here's 14 degrees of freedom. And then we have the area of 0.05. So therefore, we are going to get 1.761. So we're going to say that the t-value is equal to 1.761. Okay, and then writing that as a sentence, we would say that the t-value in the table is 1.671. And again, if we wanted to locate this on our bell curve, we would know that here would be located our mean, and we would say that the value of t is equal to 1.761. Okay, next it says find a t-value such that the area left of the t-value is 0.01 with 19 degrees of freedom. Now we're going to, it says here, hint to use symmetry. Okay, so what does it mean by symmetry? Well, that means that if we have a bell curve, okay, this is our mean, then what we have are two t-values. We have a t-value here, that's the area on the right, and then there's another t-value here, which is the area on the left. So let's go and take a look here. So we know that our area is 0.01 and our degrees of freedom is 19. So let's take a look at that. So we want 19 degrees of freedom. And our area is 0.01. And so therefore there is 0.01. And our t-value that we find there is 2.539. So we can say that the t-value and that is the area in right tail is equal to 2.539. So therefore, that's over here, 2.539, because the area in this tail is 0.01. And so if we're going to use symmetry, then we want to find the t value where the area in the left tail is also 0.01. So the area here is 0.01, but since that's to the left, that means that this is going to be negative 2.539. So then we can say that the t value in the area in the left tail is going to equal negative 2.539, which is what we're looking for, because they're asking us to find the area in the left of the t value. That's what it says. And we're using symmetry to determine what that is. So let's go ahead and write this out in a sentence. That means here that the area, or thus the t value, such the area left of the t value is 0.01 with 90 degrees of freedom is negative 2.539. Okay, next we want to find is the critical value that corresponds to 70% confidence and assume 24 degrees of freedom. So the first thing we want to do is, what we're looking for is the critical value of T alpha divided by 2. Okay, now we need to find alpha. In order to find alpha, we have 100%. We're going to subtract 70%, which gives us 30%. And 30% as a decimal is 0.30. Okay, so now what this does is this is equal to alpha. So here we're going to have t, which is 0.30. We're going to divide that by 2. So therefore this becomes t, and 0.30 divided by 2 is 0.15. So what that tells us is that we're finding the critical value that corresponds to that. So that means that we have an area here that is 0.15, and we're looking for the t value there. So we know that the degrees of freedom is 24, and we have the area of 0.15. So let's go ahead and use the table. So we're going to go and take a look at that here. So here is the degrees of freedom of 24, and then we have our area of 0.15. And so what we get is a critical value of 1.059. So therefore the critical value is going to be 1.059.